Let's talk about the basics of a series circuit. Let's examine what happens to the voltage of a charge as it passes through a circuit. Starting from the 9-volt battery, the charge exits the battery and gains a voltage. It then meets a circuit of 2 ohms. The voltage of the charge will decrease after passing through the resistor. It then meets another resistor of 5 ohms, which has a higher resistance. The voltage drop will be bigger this time. The current then returns to the circuit, and the cycle begins again. Let's look at the graph, graphing the voltage over time. Starting from 0, the charge will leave the battery and gain 9 volts because that's the voltage of the battery. After some time, it will come across resistor 1, which has 2 ohms. Since it's a relatively small resistor, it will only drop a small voltage. After some time, it will meet resistor 2, which has a resistance of 5 ohms. It will drop the remaining voltage and return to the voltage of 0. And the cycle repeats over again. Now, how do we determine how high these voltage drops are? Let's use Ohm's law. First, we must find the equivalent resistance, because Ohm's law requires the current, voltage, and the resistance. The equivalent resistance is equal to 2 ohms plus 5 ohms in the series circuit. Adding up these two resistances will give you one big resistor, 7 ohms. Now that we only have one resistor, solving this equation, V equals IR, will be much easier. We have 9V as the voltage, 7 ohms as the resistance, and we're solving for the missing variable current. Current equals 9/7 amperes. Now, what we can do with this value is plug it back into the individual resistors. What we will later learn is that inside a series circuit, the current stays the same. So 9/7 amperes will travel through the first resistor. Using V equals IR, you can find the voltage drop of this resistor. 2 ohms times 9/7 amperes will give you the voltage drop for this resistor, which will be 18/7 volts. The same current travels through 5 ohm resistor. Using the Ohm's law, we get a voltage of 45/7 amperes. Wait, Gidget, cut this. Using Ohm's law, we will get a voltage of 45. Sorry, Gidget, cut this again, please. Okay, last try. Using the voltage. Sorry, last try again. Using Ohm's law, we'll plug in 9/7 amperes and 5 ohms, and we get 45/7 volts, which will be the voltage drop for the second resistor.